For those of you that don't know me, I'm Technician Tim. And for those of you that do know me, I'm still Technician Tim. And I've got a very, very simple method to show you of measuring distance for cables in the street for Telstra. Compared to the present day one, this has got distinct advantages. So I'll show you how to connect this instrument and how to take the measurement, and it's so simple, anybody can do it without training. The cable parameter that we're going to use is capacitance. So we're going to use this particular capacitance meter that's very accurate to measure the capacitance of the Telstra cable, which doesn't change with cable gauge. To use this meter, we're going to take a characteristic of the cable called capacitance. Now, if we know the capacitance per kilometre of cable and we measure it accurately, this device will measure it to within 0.1 of a picofarad. 1 picofarad is 10 to the minus 12 of a farad. So it's a millionth of a farad that we've got this, or 1/10 of that we've got an accurate measurement for. Now, to use this instrument, I've switched it on. I push the button simply to allow the meter to calibrate and zero set. If I used another adapter in a telephone exchange which just plugs in, I can plug it into here first, zero set it, which eliminates the error that would have been introduced by that. Then I plug it into the block in the exchange and I can look out on the cable to the street. So to connect this, I've got this 10 metre length of cable, pretend cable here. I simply connect it to this particular meter's terminals. And I get a reading on this meter now of 382.2 picofarads, which, because this is 1 metre length approximately, because it's nearly 40 picofarads per metre, this 382 is roughly 10 times that length, so it's a 10 metre length of cable. I can do this just as accurately in a 10 kilometre length of cable with a 0.1 picofarad resolution. That's all there is to it. When Telstra does testing on lines, they use very complex equipment. It's very difficult to learn to understand, it's very difficult to interpret the results that you get, and it also destroys some of the faults that they're actually looking for. So the device is called the TDR, Time Domain Reflectometer. Now that's a fancy way of saying it's a pulse echo tester. It'll send a pulse of either light or electrical pulse along the line. It measures the time that it takes for the pulse to get to an imperfection. Then you get reflections or echoes sent back. You take the accurate time measurement, divide it by 2, you know the speed that the pulse travels along that particular medium, so you calculate the distance. The trouble is, the longer the line is, and for a reasonable result, you've got to have a fairly high energy pulse. On the current day TDRs, you cannot alter the amplitude, the strength of the pulse. You can alter the duration of it, the length of time it takes, but not the amplitude. The amplitude of the pulse is the destructive part. Just to summarise what we've gone through, the present day meters are relatively difficult to learn to operate. They're difficult to interpret. They need technician type training to reliably do it. The alternative method that I've got by measuring the capacitance is non-destructive, where the TDRs they use today can be destructive for the faults. Mine is more accurate. It'll measure down to 19 millimetres accuracy within a 10 kilometre length of cable, and it's simple to use. You don't need any training. So thanks very much for watching, and I wish you luck. That's for your testing. That's the easiest.